Okay, so hopefully you've now gone through that entire investigation using Desmos and graphing a whole bunch of equations and looking at how different parts of the equation affected how your graph looked. So what you're doing is you looked at a whole bunch of equations, compared them to the basic parabola y equals x squared, like the one we have here on the right, and seeing what the new graph looked like by comparison. So you could eventually, hopefully, you could look at the equation and be able to tell what the axis symmetry and what the vertex were, and whether when you compare your new graph to y equals x squared, whether it was reflected across the x-axis, whether your new graph was narrower, wider, or congruent or the same shape, and whether it was shifted left, right, up, or down. Okay, so if you look at some of the examples that you have that you've done already on that investigation, take a look at any patterns you may have discovered and try and fill in the information that's on here. So before even trying to do the graph of y equals negative 1 over 4 bracket x plus 5 all squared plus 7, try and predict where the axis symmetry is, where the vertex will be, and what this graph will look like in comparison to y equals x squared. So take a minute and try that out, and then let's take a look at the answer together. So you should wind up with something like this. So we should be able to see that from the equation we have the axis symmetry at x equals negative 5. So that came from this part of the equation right here. It's plus 5 in the equation but negative 5. So you may have noticed that when it was plus 5 in the brackets here, that your equation moved left, so it was the axis symmetry of negative 5. Your vertex here is at negative 5, 7, so negative 5 comes from the axis symmetry, and the 7 comes from the value out here. This was reflected in the x-axis, and you might be able to see that by looking at the negative value that's out in front here. This was indeed wider, okay, and I'll explain why in a sec, but hopefully you saw that pattern as well. And in terms of translation, if you're looking at the vertex here, our vertex on y equals x squared is at 0, 0. Our new vertex is at negative 5, 7, so that vertex has moved left 5, up 7, along with the entire graph. Okay, so let's take a look at this actual graph here. So here in black I have y equals x squared, and in red I've graphed our new equation, negative 1 over 4 x plus 5 all squared plus 7. So you can see the vertex has moved left 5 and up 7. Okay, so from 0, 0 to negative 5, 7. This one is wider than the original one, and it has been reflected across the x-axis because it is now opening down. Okay, so in general now, let's try and create some rules for what happens as we change any value in that equation. So if we look at our general form, y equals a bracket x minus h all squared plus k. So in your investigation, you saw different values put in for a, different values put in for h, and different values put in for k, and you saw how that affected the graph. Okay, so let's see what happens as I change the values of h, k, and a. So let's start with the a value first. That one seems to do the most. So as I make my a value bigger, okay, you'll see that my graph gets narrower and narrower and narrower compared to the original y equals x squared. Okay, you see it getting narrower. So as it gets smaller and smaller and smaller, it gets wider. And you'll see that here, once my a value gets less than 1, now my parabola is actually wider than the original y equals x squared. Okay, so it continues to do that until I start getting negative. Okay, and at negative 0.1 I'm still wider. But you'll notice that now with my a value being negative, now my parabola is opening down instead of opening up. So that's what gives me that reflection in the x-axis that we were talking about in your investigation. So as I keep going more and more negative, you'll see that again, my parabola gets narrower and narrower and narrower. So what the a value tells you, if it's negative, you've been reflected, so you're opening down. If it's positive, it's not reflected, it's opening up. And if you're comparing it to y equals x squared, if your a value is larger than 1, it's going to be narrower. But if it's between 0 and 1, it's going to be wider. Okay, and same is true for the negatives, right? If it's between 0 and 1 on the negative side, it's going to be wider, and larger than 1 on the negative side would make it narrower. Okay, so that's what the a value does. Now we can take a look at the h and k values as well. So as I move my h value, you can see it moves, as h gets larger, okay, it moves it to the right. Okay, as h gets negative, it moves to the left. Okay, one thing I'd like to point out here, let's say I have an h value of negative 5, you'll see how it's moved left in the graph. If you actually put that in the equation here, that's what gives me the x plus 5, because I have x minus, if h is negative 5, x minus negative 5, which is x plus 5, which was giving me that original graph up here. So it would be a positive, it would look like a positive in the overall final equation, but it actually means the h value is negative. So that's why it seemed to happen in reverse as what you might expect when you looked at the equation, where you had a positive in the equation, but it was actually moving left. Well, that's why it's happening, right? So if you put in a negative value for h, it gives you a positive in the equation. Okay, and last but not least, you look at your k value. As I change that, it moves the parabola up or down. Okay, and we call that a vertical shift. Okay, so let's summarize all this. So in general, if we look at at y equals a bracket x minus h all squared plus k, we can describe the transformations. So the a values we discussed tells you whether it becomes narrow or wider. Now in terms of the actual transformations, we call that a vertical stretch or vertical compression by a factor of a. Now these signs right here mean the absolute value of a, which means we don't include the negative. Okay, so we know that if the a value is negative, that tells us we have a reflection in the x-axis. So if we ignore the negative on it and just take the a value that's there, we actually would describe the vertical stretch compression factor. So what I'll do after is I'll apply all this to the one we just did, just so we can name the transformations. But the a tells us how narrow or how wide our parabola is, whether it's been vertically stretched or compressed compared to y equals x squared, and if it's negative, it tells us we have a reflection. Okay, h, as we saw on the graph, tells us how much we've shifted left to right, so we call that a horizontal translation or horizontal shift. And for our k value, same idea, but it's a vertical translation or a vertical shift. Okay, so what I'm going to do here is I'm going to apply to the equation we just did, I'm going to list these transformations. Okay, so what I'm going to do here, I'm going to start with the negative out in front here. So because my a value is negative, we have a reflection in the x-axis. Okay, because our new graph was wider than the original y equals x squared, and we saw here that our a value, it's negative 1/4, but if you ignore the negative, we just have a 1/4 here. So that's between 0 and 1. We call that a vertical compression. Okay, and we're going to say it's a vertical compression of factor 1/4. Okay, so we saw when we had the 5 here that made it move left 5. Okay, and that plus 7 here outside made it go up 7. So these are the transformations that have happened to go from y equals x squared to the graph that we just finished drawing. Okay, so what we're going to try and do now is we're going to look at, again, at the basic quadratic function y equals x squared and a transform version. And what we're going to do is look at the two graphs, and we're trying and look at some rules to how we can create the new graph using the original graph. Okay, the end goal here is to be able to create a graph of any quadratic equation we want just by using transformations. Okay, so all the equations that you've done, the ones that you did in the investigation, were just transformed versions of y equals x squared. And in theory, we can use the transformations to graph any parabola we want. Okay, so that's in general what we're going to be trying to do. We're going to create something called a mapping rule, which you've never seen that term before. We're going to describe that as we go through the following example. So here I have y equals x squared, and I have a transform version y equals negative 2 bracket x plus 1 all squared plus 8. Okay, so and here I have the graphs for each one. Now, normally you're not going to have the graphs for each one. Okay, we're trying to use this to sort of create a rule of how we can get from one graph to the next. But again, our end goal is to create a rule that will somehow let us create this graph without having to go through tons of work. So what I have you do first is I want you to take the equation y equals negative 2 bracket x plus 1 squared plus 8, and I would like you to start by listing the transformations. Okay, so take a minute and list the transformations next to the stars here in your notes, and push play and you're ready to go through the answers. Okay, so if you look at the negative 2 out here, the negative 2 does two things. The negative part gives us a reflection in the x-axis. Okay, the 2 gives us a vertical stretch. Okay, that number here there is larger than 1, so it's a vertical stretch. It makes the parabola narrower. We call it a vertical stretch by a factor of 2. And the plus 1 here shifts us left 1. The plus 8 here moves us up 8, so we go left 1, up 8. And what I'm going to do here is I'm going to take points that are on y equals x squared. I've indicated two of them here, 0, 0, and 1, 1. And I'm going to take these points and go through all these transformations to them and see what happens to those points after we do those transformations. Okay, so what I'm going to do is I'm going to start here with 0, 0. Now, if I take the point 0, 0 here and I reflect it across the x-axis, think about what's going to happen to it. So when we're doing a reflection across the x-axis, Picture the x-axis as being your mirror. We're trying to reflect it across there. So in the case of 0, 0 here, it's already on the x-axis, so that reflection isn't going to do anything. So even after that reflection, it's just going to stay the same. Okay, so I reflected it. Next thing I'm going to do is I'm going to do a vertical stretch by a factor of 2. Now, if you think about a vertical stretch, well, which coordinates do you think that's going to affect? The x values or the y values? Well, it's the y values that give you the vertical coordinate on the graph, the vertical position of it. So the vertical stretch will affect the y values, and it's by a factor of 2. So what we're actually doing with a vertical stretch of a factor of 2 is we're multiplying all the y values by 2. So my y value here of this point is 0. So if I multiply that by 2, I still get 0. So after the vertical stretch, again, this point has not moved. So nothing too exciting has happened so far. Next what I'm going to do is I'm going to take this point and I'm going to move it left 1 and up 8. So again, from this point, that's still at 0, 0. I'm going to go left 1 and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I wind up here. Okay, so the coordinates of this point are negative 1, 8. And if you look here at our other graph over here, this is a point that is on our new parabola. Okay, so again, I took this point 0, 0. I went through all these transformations. When I was finished, I wound up at negative 1, 8, which was a point, actually the vertex of the new parabola. Okay, I'm going to repeat this process with the point 1, 1. Now, just to summarize here, you're wondering what this notation is down here. This is called a mapping. So I took 0, 0, and I went through all these transformations, and it mapped that point from 0, 0 to the point negative 1, 8. Okay, and I'm going to repeat this process with a point 1, 1, again, just to see what happens. Okay, so I'm going to take the point 1, 1. So first thing I'm going to do is reflect it across the x-axis. So the points here, are, if I reflect it across the x-axis, it's going to go same distance but on the other side, so it's going to be over here. Okay, so now the y value of this point has gone from being 1 to negative 1. Okay, so now, after I do the reflection, I'm going to do a vertical stretch by a factor 2. So if you remember what that means, I take the y value of the point and multiply it by 2. So my y value here is negative 1. I multiply that by 2, and I get a y value of negative 2. So after the vertical stretch, I've now gone down there. And now, last but not least, I'm again going to go from there left 1 and then up 8. So I go left 1, I'm over here on the y-axis at negative 2, and then I go up 8 from there, puts me up to 6. Okay, so this is telling me that this point is that started at 1, 1, after the reflection, the vertical stretch, the left 1, and the up 8, wound up at 0, 6. Okay, and again, if you look at the point 0, 6, it exists on our new graph over here. Okay, and just so I can have you do one on your own, I'm going to have you guys try doing this exact same thing for the point 2, 4. So take this point 2, 4 that's on your sheet in front of you, and again, go through these transformations and see where it winds up. Okay, so you start with 2, 4 and see where that point maps to. Okay, so again, push play when you're ready to go through it together. Okay, so I'll go through this quickly. So first thing you do is you take this point, reflect it across the x-axis. So it goes from 4 above the x-axis to 4 below. It's going to be down here. Okay, vertical stretch by a factor 2 doubles the y value. My y value goes from negative 4 down to negative 8. And now it goes left 1, up 8, and I wind up at the point 1, 0. Which again is a point that is on the parabola. Right? Now, this is all well and good, but this is going to be very, very tedious. If for every time we want to graph a parabola, I take all these points, draw all these transformations, figure out where they wound up, and then make the graph from there. It would take a very long time. So what we want to try and do is create a general rule that will work for any point we want. Okay, because then we can calculate where it goes instead of actually having to make a graph every single time. So let's try and create this here. So I want to see what happens to a general point xy. Okay, and so I want you to think about first what happens to the general point xy. See if you can come up with a rule what happens to all the x and y values, and we're going to take this up in part 2 of the video.